Hello and welcome to this solution video of paper 42 May-June 2023 of A and AS level Mechanics 1 of Cambridge University International Examinations. If you like this video, please share with your friends, give it a thumbs up and subscribe to my channel. I'll be making many more videos like this in future for you guys. Okay, the question number 1. A particle of mass 1.6 kg, so mass is given to us, is dropped from a height of 9 meters. So just dropped. It was here and it was just let go above horizontal ground. So 9 meters, this is 9 meters above horizontal ground. The speed of the particle at instant before hitting the ground is 12 meter per second. Just before this particular moment, it is 12 meter per second the velocity. Find the work done against air resistance. Okay, so we'll use energy equation here, where the work done by the applied force is the sum of work done by the resistive force plus change in kinetic energy and change in potential energy, right? Since it was let go at this moment, these moments, there was nothing forcing it down physically except for gravity. So applied force in this case will be 0. Now resistive force will be because of air resistance only in the opposite direction. Why? Because there is no friction, there is no surface to surface contact, so air is the only thing that is resisting it, and they're asking the work done by air resistance. Whatever WR we'll get will be the answer. Then change in potential energy is half m. Let me write m here. Okay, we should know the formula first. So delta KE is 1 over 2 m V final square minus V initial square. So what was the mass? Mass was given 1.6 kilograms. Then we have final velocity here, 12 meters per second, minus initial velocity. What was the velocity here? U was 0 because it was just dropped. It was not thrown down. It was just dropped, let go. So that will be change in kinetic energy. What about change in potential energy? This is the work done by the gravity that we were talking about. So there is no external applied force, but the work done by the gravity is actually the change in potential energy, and change in potential energy is mg final height minus initial height. Now you will be saying that, okay, the work is being done, it should have been here, it is being applied, right? This should have been on this side, but let's see what happens here. So it will be 1.6 times 10, the acceleration due to gravity. Final height is 0. It reached the ground. So height from the ground will be 0 minus what was the initial height? 9 meters from the ground. So 9. So what will that be now? Resistive force. This can cancel. 0.8 times 144. Here it will be 16 times minus 9, and now you can see that it came out to be negative, change in potential energy. So actually when it goes to the left side here, it becomes positive and becomes a part of applied work done by the applied force. So we did not change our energy equation, but indirectly it gave us what we wanted. So let's bring it here. 16 times 9 is 144. So 144 becomes positive, but this will become negative, which is 115.2. okay, equal to WR, work done by the resistive force, and WR comes out to be 28.8 joules. Question number 2. two particles of masses 3.2 kg and 2.4 kg respectively lie on a smooth. There is no resistance, that means horizontal table. So let's say this is the table. This is first particle and this is second particle. The mass of this one is 3.2 kg. This one is 2.4 kg. Okay. Which is moving towards A with a speed of 6 meters per second, and A moves towards B with a speed of V meters per second. So this is coming here V meters per second, this is coming here 6 meters per second. Okay, and they collide and they come to rest. Find the value of V. So due to conservation of momentum, what was the momentum before? So let's say momentum before, let me write here, m1 v1 plus m2 v2, mass of first times its velocity plus mass of second times its velocity. So 3.2 is the mass of the first one, v is its velocity, plus 2.4 kg is the mass of the second one, but its velocity is minus 6 because it's in opposite direction. That means this v is going to be positive. We are considering positive and it will come out to be positive. So conservation of momentum says that whatever is the momentum before collision is equal to the momentum after. So initial momentum was this, final momentum, both bodies are at rest. So m1 times 0 and m2 times 0, which is 0. And we will see what is the v here. 3.2 v minus 14.4 equal to 0. So 3.2 v equal to 14.4. v equal to 14.4 divided by 3.2, which will be 4.5 meters per second. And now we have B part also here. Find the loss of kinetic energy of the system. The system means both of them together due to collision. So change in kinetic energy or loss of kinetic energy in this case will be again half m v final square minus half mv initial square for both. Okay, we'll find the final kinetic energy for both. So let's find final kinetic energy for both, which is half 3.2 times 0 square for the first one, half times 2.4 times 0 square is for the second one, and then we'll subtract the initial ones, half times 3.2 and the initial velocity v for the first one is 4.5 square, and we'll subtract the second one also, half times 2.4 times 6 square. In this case we are not going to write it minus 6 square, because even if we write a square will make it positive, but energy is not vector, so we'll write it like this. So this is 0, this is 0. So what we'll get will be the answer from here. So 1.6 times 4.5 square minus minus 1.6, minus means loss, so don't take it as a vector. 4.5 will be 20.25 minus this will also cancel, 1.2 times 6 square, 36. Put these in your calculator and you will get the answer. By the time I do this, I would request you to like this video, share with your friends, and subscribe to my channel. I'll be preparing many more videos for you in future too. So I got 75.6 joules negative, that is, but since there we are writing, they're asking the loss in kinetic energy, so we will not write negative, we will write loss. Well, question number 3 says coplanar forces of magnitudes 30 Newton, 15 Newton, 33 Newtons and P Newtons act at a point. This is the point in the directions shown. Okay, different directions shown in the diagram where tan alpha is 3/4. Okay, so alpha angle can be found out, but I don't think we'll need it. The system is in equilibrium. That means all forces in all directions are balanced out. Show that something square plus something square is equal to 1. Does it remind you something? That reminds me sine square theta plus cos square theta equal to 1. So we'll see if we need alpha, but no, alpha is given here. So I think theta is the one we have to isolate. So let's see. Let's first resolve these forces in different directions. So the components in this direction. For this 15 Newton, because angle is here, it will be 15 cos alpha. This 33 again has an angle with this component, so it will be 33 cos alpha. Similarly here it will be 30 cos theta plus p cos theta. Why cos in all of them? Because angles are with this x direction force, so all of them are coses. That means the others will be sine vertically. So this will be 33 sine alpha plus p sine theta. Here this component of this 15 will be 15 sine alpha and it will be 30 sine theta. Okay, since the system is in equilibrium, we will equate the equations. Now let me equate these horizontal ones. So resultant of horizontal is 0, right? So let's make them equal now. 30 cos, I did not write 30, cos theta plus p cos theta is equal to 15 cos alpha plus 33 cos alpha. We have cos theta common here and that we want to isolate. So what is left here? 30 plus p. 30 plus p, yeah, p plus 30 is here, so we are close. Equal to, both of them are cos alpha, so we'll add them 48 cos alpha. So cos theta is to be isolated, so it will be isolated by bringing this 30 plus p as a denominator here. 48 cos alpha divided by 30 plus p. We can further evaluate, give it a value. How this cos alpha can be evaluated? They said tan alpha, and when I saw it again, because this has been typed by me, it was not 3/4, actually it was 4/3. So I'll have to change this. So tan alpha is 4/3. For that, let me draw a right angle triangle where tan alpha is 4/3. So if this is alpha, opposite will be 4, adjacent will be 3, because tan alpha will be opposite over adjacent. By Pythagorean, if you find the third side, it will be 5. Yeah, 4 square plus 3 square is 25. Square root of 25 is 5. So we can substitute this cos alpha now. It will be 48 multiplied by cos alpha. Cos is adjacent over hypotenuse. So 3/5 divided by 30 plus p. And 48 multiplied by 3/5 will be 28.8 for sure. So cos theta rather, comes out to be 28.8 over 30 plus p, or p plus 30. They have written p plus 30 here. That's correct for us also. So let's talk about the vertical forces now. These vertical forces. So 30 sine theta plus 15 sine alpha equal to 33 sine alpha plus p sine theta. So let's combine thetas and alphas together. So let me bring this. They want p to be negative? Yes. So let me bring this one to the left side. So it will be 30 sine theta minus p sine theta, which will be equal to 33 sine alpha minus 15 sine alpha. So again, just like this, we will take common 30 minus p sine theta will be equal to how much? 33 minus 15, 18 sine alpha. Again isolate sine theta, which will be 18 sine alpha over 30 minus p. Sine alpha according to this drawing will be 4 opposite over hypotenuse, 4 over 5. So 18 4 over 5 over 30 minus p, and definitely it is going to be 14.4 over 30 minus p, and we know that sine square theta plus cos square theta equal to 1. So sine square theta, let's say this is sine theta, right? Yeah, sine theta came out with this, so we can write 14.4 over 30 minus p square plus cos theta came out to be 28.8 over 30 plus p square equal to 1. Whatever they wanted us to show, we have done that. Okay, they may have b part also. Now we have to verify. Verify means we don't have to calculate much. Verify, just verify that p equal to 6 satisfies this equation. So we'll just put p equal to 6 here and it should satisfy the equation. So 14.4 over 30 minus 6. Yeah, in place of p, I'm writing 6 square plus 28.8 over 30 plus 6 square equal to 1. Put these in a calculator and you will definitely see that 1 is equal to 1. Both sides will have 1. It is verified. Question 4. An athlete of mass 84 kg is running along a straight road. Okay, so this is the road and the athlete is running on it. Okay. Initially the road is horizontal, of course it is horizontal, and he runs at a constant speed, okay, of 3 meters per second. So constant speed, okay, that means there is no acceleration. The athlete produces a constant power of 60 watt. So every moment the power is 60 watt means 60 joules of energy is being used up every second. So at every moment this is the speed and this is the power. Find the resistive force which acts on an athlete. Okay, so we know that the net force on any body is the difference of applied force and the resistive force. So since the speed is constant, that means both of them are balanced and F net is 0. So we can say that applied force, whatever force is being applied, is same as the resistive force. And how can we find applied force? We know this power is the applied force multiplied by the speed. Power is how much? 60. Force applied we want to find out, and speed is 3. So applied force is 60 divided by 3, which is 20 newtons. But the question was find the resistive force which acts. So Fr will also be 20 newtons because they are balanced out because of the constant speed. Okay, what next? The athlete then runs a section of a road which is inclined at 0.8 to the degrees to the horizontal. Okay, let me write degrees here, and runs a section of 150 meter. The length of that section is 150 meter, which I forgot to write here. So he was coming like this, and then he starts climbing on the section which is 0.8 degrees to the horizontal. It is looking like much more than 0.8, but for the simplicity's sake, I've done this way. Okay, the speed at the start of the section is 3 meter. Of course, he was running 3 meter per second before this, so here also the speed is 3 meters per second. And now he produces a constant driving force of 24 newtons. So not work, the force which is applied by the athlete is 24 newton. Total resistive force here is 13 newtons. So Fr equal to 13 newtons. Use an energy. Okay, we can't use forces. We have to use energy method to find the speed of athlete at the end of 150 meter section. So this is 150 meter section, and at this, what is the final speed? That's what they're saying. Okay, so we have to use energy. So we will use energy equation that we used in question number 1 also. So work done by the applied force is the sum of work done by the resistive force plus change in potential energy plus change in kinetic energy. So applied force is 24 newtons. We know work done is force multiplied by the distance it causes for displacement it causes, and because both are having a 0 degrees with it, there's no need to write cos 0 here, so F times D is enough. So 24 newtons times, what is the distance? 150 meters. Resistive force is 13 newtons, and again it will be multiplied with distance because that is the work done by resistive force. Delta PE, we have already discussed it earlier. Delta PE is mg final height minus initial height. Okay, so m is 84 kgs for the athlete. Let me confirm. Yes, 84 kg was the mass of the athlete. Okay, G is 10. Final height is this height, right? Let me call this height as h. Okay, so h divided by 150, opposite divided by hypotenuse is equal to sine 0.8 degrees. So h equal to 150 sine 0.8 degrees, that I'm going to write here in place of final height. 150 sine 0.8 minus, what was the height earlier? It started from here, height was 0. Now we have to talk about delta Ke, difference in kinetic energy. So it will be half mass final velocity square minus initial velocity square. So half mass is 84. They are saying at the end of 150 meters section, what is the speed? That means Vf is being asked. Vf square minus, and initially it was 3 meter per second at the start of this section, so 3 square. Everything is with us except for Vf that we can find now. So 24 times 150, 3600, and if I multiply this 1950, but if I bring it to the left side, it will be negative. 1950 minus this plus will also become minus, so 840 times 150 sine 0.8, 0 we can ignore, equal to, we can cancel this, 42, which comes out to be 109 109.234. So 109.23, let's write 109.23 equal to 42 Vf square minus 9. Okay, so now this 42 can divide the left side so that we can find the value of Vs square. So it is comes out 2.6 equal to Vf square minus 9. This minus 9 has to come to the left side, so it becomes 11.6 equal to Vf square, and we will square root both sides. What does Vf comes out to be? Square root of 11.6 will be 3.4 meters per second. So he speeds up actually while climbing this distance by applying this much force. Question number 5. A particle of mass 0.6 kg is placed on a rough plane, that means there will be friction, which is inclined at an angle of 35 degrees to the horizontal. The particle is kept in equilibrium, that is all forces on the particle are equal, by a horizontal force, this one, okay, P newtons, acting on a vertical plane which has this line of greater slope, and the force, okay. The coefficient of friction is between particle and the plane is 0.4. Find the least possible value. First of all, we should understand why they have said least possible. That means we should just hold it. We should not let it slide down, okay. Which force is making it slide down? The component of the weight. The weight of this will be 0.6 times 10. 6 newtons will be the weight this way. Its component in down the slope is always 6, the weight itself, and its sine component with 35 degrees this angle. This will be the force which will be responsible for it to go down. But they're saying least possible force. That means there is some force already which is trying to resist it, and which will be in this direction, and that force will be friction, which will not let it or slow it down to slide it down. So this force minus friction, whatever is left, will be provided by P Newton, and that will become the least possible value. So we can write this here. 6 sine 35, to make it in equilibrium, it should be equal to the force of friction plus the component of P. Why did I write component of P, not P? Because P is in horizontal direction, whereas this motion is in this inclined direction. So we can't use P. We have to use its component. And how do I find component? We never find component from the head of the force. We will have to pass it here, so that P is now having tail at the object, and its helping force, which is in adding to the friction, will be P cos, and this angle which is 35 degrees, again corresponding angle 35 degrees. Okay, so in place of component of P, I can also write P cos 35 degrees. Okay, now challenge here is to find friction. Let me do it here. Friction is the coefficient of friction mu times the resistive force R. Not resistive force, actually the normal contact force. So normal contact force is in this direction, which is 90 degree. Now that's why it's called normal. Normal means 90 degree to the surface, which will be equal to this force, which is the component of 6 Newton. This was sine component, this down the plane. This is 90 degree here to this line, so it will be cos component, which will be 6 cos 35 degrees, and this will also be 6 cos 35 degrees. Okay, but there's a problem. Because of this P, there will be a component in this direction also. So we had P cos 35 in this direction, we will have P sine 35 in this direction. That means this reaction force, normal contact force, will be the sum of these two. So I will have to add P sine 35 here also, because this particle is in equilibrium. It is not flying off the surface or sinking inside. That means these two forces are equal to the normal contact force, and that's what I will use here now. So let me write 6 sine 35 equal to friction force. Now mu, coefficient friction, is 0.4, which is given in the question, and then r we just got that these two are r's. So I will write here 6 cos 35 plus P sine 35. And then we have P cos 35. This becomes the equation, and this will help us to find P, because P is the only unknown part here. So let's first write what is 6 sine 35 is 3.4414. I am taking maximum digits so that my answer is accurate. 3.4414 equal to, let me first do this one, 0.4 times 6 cos 35, which becomes 2.4 cos 35, 1.9659, 1.9659, and then 0.4 will multiply here also. So 0.4 times sine 35 will be 0.2294 plus 0.2294 P, because P is there, we can't ignore it. Then we have cos 35 P. So cos 35 0.8192, 0.8192 P. So now we have P here, we can add them, plus 0.2294, 1.048, 1.0486, 1.0486 P. These two added, and this is what I got, and I will subtract this from this, because when it comes to the left becomes negative. So 3.4414 minus 1.9659, 1.9659 is 1.4755. So P will be 1.4755 over 1.0486. By the time I do this, I would request you to like this video, share with your friends, and subscribe to my channel. That will motivate me to make many more videos like this. What I got is P equal to 1.407. So I can write 1.41 Newton. This is the minimum force you need to apply so that this particle stays where it is. Question 6. A particle P starts at rest and moves in a straight line from a point O. So suppose this is the straight line, this is the point O, and P starts from here in this direction. Okay, what it means that it starts from rest. That means at when time is 0, its velocity was 0. That's why it started from rest. And of course the displacement at that time was also 0, because it was on the point O. Okay, this is what we interpret from what they've given here. So the velocity of P v meters per second is given by v equal to bt plus 3 plus ct to the power 3 over 2, which is not written here. I will write here 3 over 2 power of this t, where b and c are constants. P has a velocity of 8 meter per second when t is 4, and this when t is 9. Show that b is equal to 3 and c is equal to 0.5. Straightforward, because they have given velocity at time. So we will substitute v and t in this and we'll get equations. So first condition, velocity is 8, which is this velocity is 8, equal to b time is 4 plus c time is 4 again to the power 3 over 2. So let's simplify this. 8 equal to 4b plus 4 to the power 3 over 2 will be 8, so 8c. So let's divide all of them by 4 to simplify. That's what we can do on any equation if all of them can be divisible by the same number. So 2 equal to b plus 2c. This is our simultaneous equation number 1. Let's do the same thing with the second case. 13.5 is the velocity, so v is 13.5. Time is 9, so b 9 plus c 9 to the power 3 over 2. So 13.5 equal to 9b, and this will be 27 plus 27c. Please use your calculator if you want to ensure if this thing is correct. Okay, all of them are multiple of 4.5. To simplify this, I'll divide it all of them by 4.5 to simplify. You can keep them like this, but the calculations will be larger. That's why I'm simplifying. So 3 equal to 2b plus 6c. This is simultaneous equation number 2. Now I will use elimination method of solving simultaneous equation in these two. This is 6c, this is 2c. So let's multiply this whole equation by 3. So what do I get? 2 times 3 will be 6. 3 times b will be 3b. So equal to 3b plus 6c. That's what this equation becomes if I multiply the whole equation by 3. Now second one was 3 equal to 2b plus 6c. I did not change the second one, and I will subtract this. 6 divided by 3, 6 minus 3 is 3. 3 minus 2 is just 1, so b, and they cancel. 6 minus 6 is 0. So b is equal to 3. This is what they wanted us to show. B is 3. And now I can use any one. Let me use this equation to find c. So equation 1. 2 equal to b is 3 now. So 3 plus 2c. Now 2 minus 3 on the left side equal to 2c, minus 1 equal to 2c. So c becomes negative half or negative 0.5, which they wanted us to show. So done this one also. Next part says find the acceleration of p when t is 1. We don't have the equation for acceleration. We have equation for velocity. To convert into acceleration, we'll differentiate both sides. So a is nothing but dv over dt. So this one differentiated with respect to t. Differentiation of bt will be just b. Differentiation of c to the power 3 over 2. So 3 will be plus 3 over 2c t, and then the exponent goes down by 1. Let's substitute the values of b and c because we know them now. Okay, so a will be equal to 3 plus 3 over 2 times negative 0.5, that was c, and t is 1 they have given here. So 1 to the power half. 3 over 2 minus 1 is half. Okay, so 1 to the power half is 1. So let's focus on this only. 3 minus minus 3 times 0.5 will be 1.5 over 2. 1.5, yes, that is 0.75. So which will be 2.25 meters per second square. This is what the acceleration is when t is 1. Next, find the positive value of t when p is at instantaneous rest. Means for a moment it is at rest. At rest also means v, the speed velocity, is equal to 0. And this equation of velocity was v equal to 3t, which is bt. B value is 3, so minus 0.5 t to the power 3 over 2. Let me confirm. Yes. So B and C I have substituted. So 3 over 2. Yeah, 3 over 2 is the right power. Okay. So they said it is at instantaneous rest. That means velocity is 0, equal to 3t minus 0.5 t to the power 3 over 2. So let's take t common from here. So t is taken out. We are left with 3 here minus 0.5, and out of 3 over 2, 1 is out. This t to the power 1 is out. So what is left in this? We'll subtract 1 from 3 over 2. So that comes out to be 1 half. So t to the power half. Okay. Whenever two parts multiply to 0, both of them can be written equal to 0. T equal to 0. At time equal to 0, it was at rest, and which is correct. In the first line itself they said so. So this is of no use. We already know this, right? This is what will give us some answer. 3 minus 0.5 t to the power half equal to 0. Let's bring 3 to the right side. So minus 0.5 t to the power half equal to negative 3 when it comes to right. Divide both sides by negative 0.5. Cancels. And we are left with t to the power half equal to, both negatives cancel here too. 3 divided 0.5 is 6. And to get t, we will have to square both sides now. So t will be 36 seconds. So find the positive value of t when p is at instantaneous rest, that is 36 seconds, and find the distance of p from O at this distance, at this instant. So look here. If suppose it reached here, not here, somewhere here, and this is t equal to 36 when it reached here, they are saying find the distance between this point and O. So basically they are asking us the displacement. No matter where is it at t equal to 36, it will always be displacement, and that makes our job easier. That means we have to find displacement at t equal to 36, but we know the equation of velocity only. So we'll get equation of displacement from this. For that we will integrate. So I'll integrate both sides to get displacement. So I integrated this. I will integrate here also. So it will be 3t dt minus 0.5 t to the power 3 over 2 dt. Okay, so integration of velocity is displacement. So s equal to, this will be the integration of 3t minus 0.5 will remain 0.5, and this will go up, the exponent will go up by 1. So 3 over 2 plus 1, same 3 over 2 plus 1 here also, and plus c. So to find c, as we discussed earlier, when the time was 0, the displacement was 0. Yeah, when time was 0, displacement was 0. So we will use this fact to find the value of c here. So this is 0. Time is 0, that means this whole thing will be 0. Again time is 0 here, this whole thing is 0 plus c. That means c is insignificant in this case. So we will just substitute t equal to 36 straight away. So s equal to 3 over 2 36 square minus 0.5 36 to the power how much? 3 over 2 plus 1 5 over 2 divided by 5, and I will write divided by 2 on top because denominator of a denominator is numerator, and there's no need to write c anymore now. So s equal to, if I write this one, I get 19,944. Since I'm doing this without a marking scheme, so you can see if there's any calculation mistake and you correct that. Though I have tried to be very careful. 2 times 0.5 is 1, so no need to count. This one will be 1555.2, which is 388.8 meters, and you can round it off to 389 meters. So it is on the positive side only, not negative side as I assumed. So that's the distance of P at t equal to 36 from O. So D part is asking to find the speed of P at the instant it returns to O. Returns to O. That means this is O. It goes, comes back, maybe it crosses, comes back, crosses. So when it reaches here, you have to find what is the speed at that moment here. Okay, so we'll find first when is it reaching here again. For that we know that the displacement at O is 0, so we'll make this displacement, what is the equation? This is the equation, equal to 0. So 0 equal to 3t square over 2 minus 0.5 t to the power 5 over 2 over 5. Okay, this was already 1, so let's ignore this because denominator of 2 will make it 1. Okay, this is the, so again we'll factor this. So t square we can take common because t square is smaller out of these two. T square, so 3 over 2 minus out of 5 over 2, if 2 is out, so just half is left, over 5. Again it gives us t equal to 0. At that time displacement was 0, we are sure about this, we already knew this. So this is the one which is going to give us the answer, 3 over 2 minus t to the power half over 5 equal to 0. Let's bring it to the other side. So minus t to the power half over 5 equal to negative 3 over 2 square. Both sides we can cancel this and then square to get rid of this half. So what do we get? T over 25 equal to 9 over 4. And let's complete here. T is 9 times 25 over 4, which comes out to be how much? 56.25. This is the time when it returns back to the same point again, O, right? So we'll use this to find the speed now, and for speed we know, because this, where is the velocity? This is the velocity equation. We'll ignore the sign because they are saying speed, so we'll just substitute 56.25 in this and we'll get our speed. So let me do this here. So V equal to 3 times 56.25 minus 0.5, 56.25 to the power 3 over 2. Let me use my calculator again, and by the time I do this, I will request you to please like this video, share with your friends, and subscribe to my channel, which will motivate me to make many more videos like this. I get an answer, minus 42.1875, and since this asks the speed only, so we'll ignore the sign. It means that it was coming towards Obviously it is coming towards the point O, so we'll ignore this for speed, and 3 significant figures will be 42.2 meters per second. Question 7. Two particles P and Q of masses 2 kg and 0.25 kg respectively are connected as shown like this with a string, and it is on an inclined plane which is inclined at 30 degrees, and it is just hanging. 0.25 kg mass is hanging. Okay, and they have given more information here. A part 1 says find the acceleration of P from A here to B, which is 0.8 meters apart. But this one is a rough surface and its coefficient of friction is 0.3. This is what they're saying. So this will become a little complicated, so let me draw it here. Okay, so the mass downwards will be its weight downwards will be 20 newtons because it's 2 kilograms. So downwards its weight will be 20 newtons, and this way the component of this 20 in this way will be 20 sine 30 degrees, right? This is the force which will try to bring it down, and it is actually bringing it down because they have said that it is released from rest and it starts moving down. That means it is moving down, but what force is trying to stop it? The tension in this string will try to stop it. And what is that force which is there? The weight of this, which is 2.5 Newton, will be responsible for causing that tension, and then bringing it backwards. Okay, the whole system, I say that this is the one which is trying to stop it, and this is trying to take it down. So 2.5 Newton will be here if I take the whole system. Okay, but there is one more force which will be backwards, which will also be further stopping it from going, which is friction. Let's call it F, friction. Okay, so the net force, F net, will be the difference of these forces. 20 sine 30 is in positive direction, but 2.5 and friction are in opposite direction, right? So let's find what is F net. Sine 30 is half, so 20 sine 30 will be 10 minus 2.5, and this F, friction, is always mu r, like we did one of the previous questions. And what is mu? 0.3. They've given 0.3. R is the one which will be the normal contact force, and it is always equal to, will be in this direction, will be the vertical, this y component of 20 newtons. So it will be 20 cos, the other one was sine, this will be cos 30 degrees. So in place of this F we can write 0.3 multiplied by 2.5, no, not 2.5, 20 cos 30 degrees, 20. Okay, so this bracket closed, one more bracket. Okay, so now F net, everything is there with us, so we can find it. So if I do it, I get 2.5 plus, so it will be 6 multiplied by cos 30 is the square root 3 over 2. This cancels here. Okay, you can put this in a calculator. What I'm getting is 2.3 newtons. This is the net force in this system, but we want acceleration. Net F net is nothing but mass multiplied by acceleration, which is 2.3 newtons in this case. So acceleration will be 2.3 divided by mass. But the mass, this system is not only taking these 2 kilograms, it is taking 0.25 kilograms along. That means this mass will be the sum of the two. So it will be 2.3 divided by 2.25. So that acceleration is 1.024 meters per second square, rounded off to 1.02 meter per second square. Okay, hence find the speed of P at C, not B. This acceleration will help us to find the velocity speed at B, not C. So if it is A and it reaches B first and then it reaches C. So let's find V here. So U, because it was just released from rest, so U is 0, right? So we can use V square equal to U square plus 2AS. This is the formula for us. V is square root, because of square I'm square rooting the other side, so U square 0 plus 2 times acceleration we just got 1.024. S, we already know the distance between A and B is 0.8 meters. So 0.8 meters. Just find this and it will give us the V here. What I'm getting is 1.28 meters per second, 3 significant figures. Now, next distance from B to C is 1.2 meters, but this surface is smooth. That means the acceleration will be more in this case. Why? Because one force has reduced. This frictional force. We will have just F net equal to 10 minus 2.5. That's it. No friction. This is what we're going to do now. So first let's find F net will be 10 minus 2.5 equal to 7.5 newtons. So acceleration will be 7.5 divided by mass, and again both of the masses are moving, so 2.25. So it comes out to be 3.29 meters per second square. Okay, that's acceleration, but we are interested in velocity. So let's call it V1, and the V2 is the one which we are interested in. So V2 square will be V1 square plus 2AS by the same logic. So V2 will be square root V1 square. V1 we got how much? 1.28. 1.28 square plus 2 times acceleration this time is 3.29, obviously more than before, and S is 1.2 meters. Let's see how much it gives me. By the time I do this, I request again you to like this video, share with your friends, and subscribe to my channel. I will make many more videos like this for you. It comes out to be 3.0877. So I can write 3 significant figures, 3.09 meters per second. The question was find the speed at C. This is the speed at C. Okay. Find the time taken by P to travel from A to C. So we will find first A to B. Yeah, how much time it takes. So we know that V is U plus AT, right? V we know now, which was 1.28. This is what we got here. 1.28 equal to initial velocity was 0 plus acceleration was 1.024 for that rough patch. Okay, and T. So it gives us T equal to, let's call it T1 because it is from A to B, right? Let's call it T1. It will be 1.28 divided by 1.024 by this equation, because 0 is excluded. It comes out to be 1.25 seconds rounded off to 3 segment figures. All right. Now B to C. By same method, V2 equal to V1 plus AT. Let's call it T2, okay? Because this is different time. So V2 we got as 3.088, okay? So we can write 3.09 equal to V1 was 1.28 plus acceleration we got in this case was 3.29 and T2. So we'll bring this one first to the left side. 3.09 minus 1.28 equal to 3.29 T2. So T2 is 3.09 minus 1.28 divided by 3.29, and that comes out to be how much? 0.55 seconds approximately. So question was the time travel from A to C. So A to B is 1.25. So A to C directly will be this 1.25 plus 0.55 we got from B to C. Answer is 1.8 seconds. Rounded off basically. 1.8 seconds is the time taken from A to C. This concludes the solution video of this paper 42, May-June 2023. There is no marking scheme out yet. I have solved it. If you find any mistake or anything you want to clarify, you can comment and like, share this video and subscribe to my channel, Math United. Thank you so much.